Here, I'm going to do more examples of finding extrema. This time, we don't have a graph. So I would suggest that you might use your graphing calculator. But if I don't have a graphing calculator with me today, so I'm just going to show you how to do these without a graphing calculator. But for an exam, you might want to learn how to do this on your graphing calculator. So I would get your graphing calculator, plot these, and see if you get the right answer compared to what I get. Okay, so here we have a quadratic function, and the shape of this is a parabola. It opens up because the leading coefficient is 2, it's positive. And I know this is a parabola because this is a degree 2 polynomial. So I'm just going to draw a picture here. And to find the absolute minimum, I need to find the vertex. And I can see that this does not have an absolute maximum because it goes up forever. So it just has an absolute minimum, and this would also be a local minimum. So to find the vertex, remember we use the vertex formula, x equals minus b over 2a. And in this example, b is -3, so this is going to be 3 over 2 times a, which is 2. Okay, so we get x equals 3/4. Now I'm going to go ahead and take this to get this is where the minimum is located, but we need to find the value of the minimum, and that is a y value. So we're going to take y equals, and we're going to plug it, if we call this function f, we're going to plug it into our function. We're going to put 3/4 in there. And so for this example, it's 2 times 3/4 squared minus 3 times 3/4 plus 4. And I'm going to go ahead and use my calculator real quick to do that. Actually, I should probably just share my screen. That might be a good idea. Okay, so we have 2 times 3/4, so 2 times 0.75 is 3/4 squared minus 3 times 0.75. And then we have plus 4. And we get 2.875. All right, so we have found the vertex. The vertex right here is 0.75 to 0.875. That's the vertex. So we can say that this function has a minimum value of 2.875, and it occurs at 0.75. So that's how you use the vertex formula when you're working with a parabola. Now, in this example here, we have the absolute value function. Again, you would graph this on your calculator, and then you would just, so this is the absolute value function, but it's been shifted, right? Okay, it's been shifted to the right by 2 units and up 3 units. So we go to the right 2 units and up 3 units. And we have that classic V shape for absolute value function. And so this is our absolute minimum, and it's also our local minimum. So we would say this point here is 2, 3. So it has an absolute minimum value of 3 at 2. Okay. I hope these examples are helping you sort this all out. You just need to practice. That's really what you need to do.